5.1 today. It's operations with polynomials. Don't write anything down. Just kind of look up here. In Algebra 1, you knew that x squared times x cubed was x to the 5th. Why did you get that? How did you get that? You added the exponents, right? So you can memorize it, or you can, some people are better this way. Multiplication has an A, so we add. Division has an S, so we subtract. Some people are better that way. Do whatever makes sense to you, okay? That's what I told my Algebra 1 kids. If you ever get on a test or a quiz and you freeze, if that's something that happens to you, you could write x 2 times. You could write 3 more, and you'd be like, oh, that was 5 of them. And you can figure out the rule on your own. Do you get what I'm saying? So, like, it's not hard to memorize, but it's not hard to come up with on your own either. Okay? So all the rules today are technically old. We're just going to do, like, harder problems with them. All right? Properties of exponents. If this is too far away and hard for you to see, you could look down, whatever works for you. So this says multiplication with the same base. These x's are called base, right? And then the a and the b are exponents or powers. So when you have the same base, you add, if it's multiplication. If it's division, you subtract. If it's a negative exponent and it's up top, you move it to the bottom. If it's negative on the bottom, you move it up top. None of this is new. You should kind of remember it from Algebra 1. If you have a power to a power, you multiply. If both of these are in parentheses, the a gets kind of distributed to both of them. Same thing here, the a gets distributed. Anything to the 0 is always 1. If you forget that rule, you could take your calculator anytime, put 100 to the 0, it's 1. Anything to the 0 is 1. Okay? None of that's new. You just haven't worked with it for a while. None of these are simplified, and you're going to help me figure out why. Why is this one not done? What could I still do? I could distribute this 4, basically. It's not really a distributive property, but take everything to the 4th power, and then it would be done. Why is this one not done? The x's. You don't want it more than once. You would combine them by doing what with their exponents? Adding them, right? Why is this not done? Simplify, right? 3 over 6 would reduce to 1/2. Very good. Why is this not done? Negative exponent. So you would move that to the bottom. Is that y squared? I can't read it. But you would just move it to the bottom. And there has to be something up top, so it would be a 1. Is that okay? I know it's kind of quick, but I feel like you should be kind of fine. All right, we're going to do number 1. It says, oh, yeah, we'll come back to the degree stuff later. We'll do that at the end, okay? So we're going to go ahead and do number 1. Literally do what it says. What are we supposed to do with the 2 and the negative 4? What's the problem wanting us to do? Multiply. What is 2 times negative 4? Negative 8. Good. A to the 3rd times a to the 2nd is a to the 5th. When you multiply, you add exponents. It's going to be b to the 2nd. Is there anything that's wrong with this? Is there anything that I need to do to finish the problem? It's fine. You can have a negative number. You can't have negative exponents. So this is totally fine. Anybody confused? Okay. This one, that 3 gets, again, it's not really the distributive property, but I don't know a better way to say it. That 3 gets distributed to everything, so it's going to be 2 cubed, which is 2 times 2 times 2. What's that? 8. A to the, that's a power to a power, so what do we do? No. Multiply, that's 6, over 3 cubed. Get out your calculator. It's okay, you could do it on your own, but I want you to get out your calculator because I want you to know how to do something cubed for when it's not this easy. So some of you have an x cubed button, and some of you have just the caret rooftop, right? So what do you get when you punch 3 cubed in? 27, and that's b to the 1 technically, and 1 times 3 is 3. Ask me a question, especially if I'm going too fast. If you go back to our rules, it's right here. Do you see that that's what we have? Okay, so that's a power to a power, so they get multiplied. The only time they get added is, see here, they both have a base. If they both have a base, you add the exponents. If they don't, it's a power to a power. Is that okay? Okay. Is there anything else I can do to that problem? Can I reduce a fraction? Can I combine anything? It's done, right? We're done. Okay? This one, everything gets taken to the third power, so you probably do need a calculator here. What is 6 to the third? 216. It's going to be g to the 15, h to the negative 12. Don't worry about any properties right now. Just multiply it out. And then I pause and I'm like, okay, why is this not finished yet? I don't like to think about that until I've done one step at a time. So why is this not okay yet? Negative exponent, it's technically in the top. Do you see that? So we're going to move it to the bottom, and now it's a positive exponent. Do you guys get that? 216 g to the 15 over h to the positive 12. Is that okay? It's not, that should be, you probably could have done that without me. Maybe you would get stuck a couple of places, but the idea is pretty easy, I think. We will cover the bottom in a second. I want to do all the normal questions first. So go to the back page. We're on number 35, okay? We'll come back to those other ones in a second. I want everybody to do the first step without me. What is the first step here, by the way? Distribute, right? Use your distributive property. Try it without me. Let's see what you get. Okay, so we get, what's this first one going to be? 10c cubed. Are you with me? Then what? Minus 15c squared plus 20c. This is going to be plus 14c squared, what? Minus 16c. Is anybody confused? That's easy. You knew what to do without me telling you what to do, right? So now you combine like terms. Typically, we try to write these in descending order, so I'm going to start with the c cubed. Are there any other c cubes? No. So you just write it down, cross it off so you don't accidentally use it again. Negative 15c squared and positive 14c squared gives me negative c squared. Cross them off. 20c and negative 16c is positive 4c. All they asked you to do was simplify. If you look at the directions, it said simplify. It did not say solve. It did not say factor. It said simplify. This is done. There's nothing else I can do. Any questions? You sure? All right. This one, cover this up with your finger. Cover this up with your finger, the 2x minus y. Okay? What would you do with these two? Foil, right? So everybody should be able to foil these without me. Ignore this for right now, okay? Foil these two and let's see what you get. Okay, when you foil, you're going to get first times first, that's 2a squared, right? That's plus 3ab, that's plus 2ab, or ba, same thing, right? Plus 3b squared. Is everybody okay with what I just did? And again, we're ignoring this for right now. It's still there, I'm just ignoring it. Do you understand that ab and ba are literally the same thing? I try to write them the exact same way so I remember that they're common terms and I can add them. But if you write A, B, and BA, that's fine too. Okay? 99% of the time, these are going to be like terms and you can combine them. So let's do that. I've got 2a squared plus 5ab plus 3b squared. Is everybody okay with what we have right now? Okay? From here, we're going to, again, you can't really call it FOIL because it's not two binomials, but we're going to distribute or whatever again. Most people tend to do better with the smaller one in front. This is a binomial because it's 2. This is a trinomial because it's 3. You don't have to do what I'm doing right now. But most people do better if the binomial is in front of the trinomial. You can multiply in any order, right? So I can switch those around if I want to. Does that make sense to you? You don't have to do what I just did. That's not a rule. It's just most people do better that way. So we're going to basically FOIL again. All right, do it with me. 2 times 2 is 4, right? And I've got an x and an a squared. So most of the time we go alphabetical descending order. So I'm going to call it a squared x. It is not wrong if you call it xa squared. I don't care. That's not the point today. Okay? So now I'm going to do this one. What sign does it get? Is it a negative or positive? Positive. What number? 2 times 5. 10. And then the letters are going to be a, b, x. Do you guys get that? Okay. So now, what sign? Positive. Number? 6b squared x. Is everybody okay? So now we're going to do the bottom part. What sign? Negative. Number? 2a squared y. All right. Sign? Minus number? 5aby. You try the last piece. What's that one going to be? Negative 3b squared y. We have multiplied everything together. Do you see any like terms? It has to be the exact same letters to the exact same exponents. Are any of these like? Nope. That is your answer. That's it. That's all you can do. Is that okay? Excuse me. Again, same idea as Algebra 1, just bigger, right? But the idea is the same. Okay. There is always more than one way to do a problem. So I'm going to do the way that I think is best and easiest for most people. And if you don't like it, let me know. I'll show you a different way later. I typically try to reduce or simplify the fraction first if possible. I think it's going to be easier to simplify this fraction and then cube what's left than cube everything now and then simplify later. That's easier for me, okay? So I'm going to ignore this 3 for right now. So what is literally 12 divided by 4? That's what it says. 3, okay? You can put over 1 if you want to for now, but you don't have to. I need to know what a cubed over a to the 6 is. I'm going to make you try it without me for just like a second because all of you guys have different Algebra 1 teachers and you may have learned it different ways. So I want to kind of see what you're going to get before I just tell you what to do. What did you get? A to the what? Let's just start there. No? Or should I just tell you what to do? Okay, here's what I do. What you just said wasn't wrong. It's just a different way to do it, okay? In Algebra 1, most of your teachers probably taught you to do top minus bottom, and then you had to move it somewhere. That's fine. There's nothing wrong with that. The problem is I think it's a little bit of extra work, okay? So let's do a to the 3rd over a to the 6th off to the side, okay? Again, you don't want to do this every time. You want to know the rule, but let's come up with it on our own. We're going to have a to the 3rd where? On the bottom. Do you see that? Because it's heavier on the bottom. There's more a's on the bottom. So when I taught Algebra 1, the trick that I used was big minus little, answer where bigger one was. Most people prefer to subtract that way anyway. Most people would rather take 6 minus 3 than 3 minus 6. Does that make sense to you? So I always do big minus little, so literally that's 6 minus 3. So my answer is a cubed somewhere. Which one was bigger, the top one or the bottom one? The bottom one. 6 is bigger than 3, right? So a to the 3 would go on the bottom. That works for me. But you can do whatever you remember from Algebra 1 if you'd like to. Most people prefer this method, I think. So these just cancel. Isn't that just a 1, right? So that line's really long. I don't need that. So 3 over a cubed to the 3rd power is what I'm dealing with now. I prefer to cube just a few things than what, 6 things? That would have been a lot of work. Do you see what I'm saying? So what's 3 cubed? 27. Use your calculator. What do I do with the 3 and the 3 for the a? Multiply. So it's a to the 9. A to the 9. There's nothing else you can do. That one's done. Questions? Okay. Next one. Again, more than one way to do it. I'm going to show you what I think is best. Okay? If you don't like it, come see me later. I'll show you 50 other options. You pick one, right? I'm going to deal with this negative exponent first. Whenever you have a negative exponent, there's a property that says that you just flip your fraction and now it's a positive exponent. I don't change anything, literally. The bottom is going to be on top and the top is going to be on bottom. I think I've said literally 50 times today. Sorry. I don't know why. I don't usually do that, do I? I haven't noticed that. Sometimes. Do I? Okay, well, sorry. Okay, you flip the fraction. I didn't hear what you said. Literally all the time? Okay. You flip the fraction, and it's now to the positive exponent of 2. Do you see that I didn't change anything inside of the fraction at all? Okay? I could, if you want to know why that works and why that's true, I'm happy to show you later. Most of you just kind of want to know the rule and do the rule, so that's the rule. If it's a negative exponent like this, flip the fraction, it's now to a positive. Is that okay? Again, I prefer to simplify in here before squaring everything. You could square everything and then simplify. It doesn't matter. I just think it's less work. Okay? So I've got a 1 over a 4, so that's just going to stay a 1 over a 4, right? I'm not changing that yet. I have x to the 1 and x to the negative 2. Again, multiple options. I do big minus little, answer where bigger one was. So I have a 1 minus a negative 2. Do you understand that that would be big minus little? So what is that? 3. So I'm going to have x to the 3 on the top or the bottom. What's bigger, 1 or negative 2? 1, right? If you don't like that, you could have done this instead. You could have moved the x to the negative 2 up. Do you see what I'm saying? Because of the negative exponent. And what's that going to be? X to the 3. That's fine too. It doesn't matter. If you're not good at subtracting like this and you never were, I don't think I'd try to fix that today, right? So here, which one's bigger, 3 or negative 4? So 3 minus negative 4 is 7. Positive 7. Would it go on top or bottom? Bottom. If you don't like that, put y to the 4 down here, and most people are good at that. That's y to the 7. Is that okay? So now I'm going to square everything. What is x cubed squared? X to the 6. What is 4 squared? 16. Y to the 14. Very good. That is the answer. That is all we can do. Questions? It's not the only way to do it. Come and see me if you didn't like it. Is that okay? Okay. This one, it's best that you simplify the numerator down to like one thing and then simplify the numerator and denominator. So what I'm saying is do the top without me. Do the top. Let's see what you get. If you can't read yours, look at mine. I think it's easier to see. These have been copied a few hundred times. So what is 5 times 2? 10. X to the 9. Y to the 8. Very good. It's still over 20x cubed y to the 5. Is everybody okay with that? Don't confuse the rules. If it's a normal number, do what you normally would. 10 over 20 reduces to 1/2. Okay? With the letters, x, 9 minus 3 is going to be 6, top or bottom? Top, right? Because the bigger one was up top. You try the y. What do you get? Y to the 3rd, top or bottom? Top. Technically, that 1 there is not only not necessary, but it's really actually kind of wrong, because what's 1 times x to the 6th? Just x to the 6th, right? I won't mark it wrong if you leave the 1, but don't. Okay? So that's done. That's all you can do. Is that okay? Okay. We'll do this one together. All right? First times first. A to the negative 3 times a to the positive 3 is a to the... They're exponents. What do you do when you multiply with exponents? Add, and you get 0. A to the 0. Huh? Well, yeah, I'm not there yet, but yes. And then b to the 3rd. Is everybody okay with that first piece? Okay. What sign am I going to have? That's a positive times a positive, so a positive. A to the negative 1, b to the 1, because 2 plus negative 1 is 1, right? What sign does this one get? Positive. A to the negative 2, b to the 0. Is that okay? So I don't simplify as I go. I write down, I do all one step at the same time. So what Jake was saying was true. He said, hey, a to the 0 is really 1, right? I don't like to do that until now, because I think it's so easy to confuse what you're doing and then you screw up, okay? So I like to multiply and then I pause and I'm like, okay, how can this be simplified further? Anything to the 0 is always 1. So 1 times b cubed is just b cubed, right? That exponent is negative, so it has to go down. So it's really b over a. Do you guys get that? And then that is a 1 over a squared, because the negative has to go down. You cannot have a negative exponent. Do you guys get that this is really a fraction right here? So it was negative up top, so I moved it to the bottom. Okay? That is it. There's nothing else you can do. If you think there is, let me know and I'll tell you why we can't. Are you guys good with that being done? You understand why? Okay? Anyone still need this page? All right. If 5 to the... Oh! Sorry. That's telling me I have to hurry. If 5 to the k plus 7 is equal to 5 to the 2k minus 3, these are called bases. If the bases are the same, then the exponents are the same. So I can set the exponents equal to one another and solve for k that way. So find k, and what do you get? 10. Anybody not getting 10 and need my help? Are you sure? So let me show you why that's actually true. If I plug 10 in, that's going to be 5 to the 17. I don't know what it is, and this is going to be 5 to the 17, isn't it? Right? So I know they're the same. I don't know what they are, but I know they're the same. So that's why it's true. Okay? The actual question was asking for k, though. I just wanted to prove to you that it's true. Okay. Let's go back to the front, and we'll finish what we didn't talk about yet. Right here is where I am right now. All right? Degree of a monomial. What's mono mean? 1. Okay? So this is all one big problem. I understand it looks like a bunch of stuff, but if there's no plus or minus in the problem, it's a mono. Okay? So the degree of a monomial is the sum of the exponents on the variables, only the variables. So I don't care about the 3 squared. That's not a variable. Do you get that? So I'm going to add the 4 and the 3, and the degree of that is a 7. Okay? If I look at the degree of a polynomial, poly means many, so more than one. Binomial, trinomial, doesn't matter. The degree of the monomial with the highest degree. So for example, 3x squared plus 2x minus 1. What's the degree here? 2. Here, 1. Here, none. So I pick the highest one, it would be 2. That's what you do. Okay? So we're down here now. Determine whether each expression is a polynomial. If it is, say the degree. So we had rules that we've talked about before, You may not remember them. Some of them are you cannot have variables being multiplied. You cannot have a variable in the denominator, which is the same as no negative exponents. You can't have fraction exponents. Basically, if it looks weird, it's probably not a polynomial. So kind of go with your gut until we get into it more. So this first one, do you think that's a polynomial? Just say yes or no. Yes, okay. The degree here is what? This 2. The degree here, 1. The degree here, it's really x to 0. So what do I pick? The degree is 2. It's the highest one. Is that okay? All right. Letter X, what do you think? Yes or no? No. Why do you think it's no? Because there's variables in the denominator or it's a negative exponent. Those are really the same thing, right? No, because you can't have negative exponents or variables in the denominator. It's the same thing. Is that okay? It's not a poly, if you want to say it that way. I don't really care as long as I can tell what you're saying. Not a polynomial because you can't have negative exponents. Do you guys get that that would really be x to the negative 1, right? This one, go with your gut, yes or no? No. Why do you think no? Because of the square root. Here's why that's not okay. The hard part about algebra 2 is sometimes you have to know things before you know them. So m minus 7 to the 1/2 is the same thing as what that says. You don't really know that yet, but this is why, because it's a fraction exponent. Anything with a square root, a cubed root, absolute value bars, those are not polynomials. Basically, if you were to give it to an algebra 1 kid and they couldn't graph the thing, it's probably not a polynomial. Okay? Questions? On your assignment tonight, your assignment sheet is not updated. I added a few questions. I wrote down, it's in the answer sheet though, which you guys usually check, but I wrote down to add 24 through 27 all. You only had like 26 or something, but your whole assignment, I'm happy to read it to you too if you want, but you can check the answer sheet. It's going to be 20, 22, 24 to 27, 32, 34, 44, 48, 56, 72, 74. It's the same as your assignment sheet. I just added a couple. So.